In this segment of ALEKS College Algebra, we will be looking at solving an exponential equation, problem type 2. And notice here then we have 27 equals 9 raised to the negative x minus 4 power, but they want us to solve for x. And so let's look at this problem over here in our notes, and here we go. Now, the number one technique here for solving such problems as these is to rewrite both sides of the equation so that we have exponentials with the same base. And so we will use an important principle. If the bases are equal, and of course it's an equation, then the exponents are forced into being equal, and then we can solve the resulting equation and we'll be done in a flash. Now the trick here then is to express these two numbers with the same base. So we look at our power and roots chart here, and what we're looking for is to find one line of the chart where both 9 and 27 occur in the same line, and we see that right here. Notice here that 9 and 27 are both in the same line of the chart, or the common base is 3, because 9 is 3 to the second power, 27 is 3 to the third power. So let's make a step. This 27 is 3 to the third power, and this 9 can be rewritten as 3 to the second power, but of course it is also raised to the negative x minus 4 power. Now, on the right hand side, when you raise a power to a power, you have to multiply the exponents. So this is going to be 3 to the negative 2x minus 8 power. We'll simply multiply these exponents here, and here we have 3 to the third. Now, we've achieved our goal now of making the bases equal. If the bases are equal, and this is equal already, these exponents here must be equal. So what we can simply do is to drop the bases altogether and simply make an equation of the exponents, because they must be equal. Now we'll just solve this as if it were a normal algebra equation, which it is, of course. And so let's move some things around. I'll move the 2x to the left-hand side. I'll move the 3 to the right-hand side. So I'll get 2x equals negative 11, and x is equal to negative 11 halves. And so this should solve the problem. Let's go back to ALEKS and enter that answer. So we will enter negative 11 halves, and let's check it.